Right, hello. I'm sorry it took me so long getting back to you. I was getting everything ready for the beginning of the course. First off, to begin with, what we're dealing with in this, your questions is dealing with the derivatives of hyperbolic and inverse hyperbolic functions. More so, we're concentrating on the inverse hyperbolic functions. So let's look at the first, the derivatives of hyperbolic functions. These are the formulas for them. So the derivative of the inverse hyperbolic sine inverse of u, where u is a function of x, so the derivative of this is the derivative of u over the square root of u squared plus 1. The derivative of the hyperbolic inverse cosine of u is similar to that of the sine, except it's negative. Then the third one is the hyperbolic inverse of tangent of some function u is equal to u prime over 1 minus u squared. No more square root on this one. And the next one is going to be the cosecant, secant, and we have to do the cotangent. So the cosecant hyperbolic inverse is equal to the negative of the first derivative over the absolute value of u times the square root of 1 plus u squared. Again, it's very similar because remember the cosecant is the inverse of the sine function. And that's why it has the 1 plus sine is, this is the same as 1 plus u squared plus 1. And for the absolute value sign, because of the period in which it travels. And then dx of the hyperbolic inverse secant of u is equal to the negative u prime of u times 1 minus u squared. Again, remember, the secant is the inverse of the cosine function, and cosine is u squared minus 1. But now this one, since the secant of the cosine function, it's positive on the right-hand side, first period. So that's why we don't have an absolute value sign there. Now, the one we're interested in is the inverse of the cotangent of u. And that one is, make sure I have a space, u squared over 1 minus u squared. So there is the one we'll be dealing with here. So our two questions dealt with cotangents. All right, let's look at your questions. The first question you had, if y equals 1 minus 7t, the hyperbolic inverse cotangent of the square root of 7t, we're looking for the derivative, this function. All right, so this is our u. Our u is defined as the square root of 7t, which is the same thing as 7t to the power 1/2, because we have to have the first derivative of that because of our formulas. Thus, for our formula, we need to know u squared. So we'd find that anyway. So the power comes down, which makes it 7t minus 1 makes it negative 1/2 times the derivative of the inside, which is 7. So this becomes 7 over 2 square root of 7t. That's u prime. We'll need this. Since this is a product, for us to take the derivative of this, this first part we'll call f of x, the second part we'll call g of x. Because in my calculus courses, when I teach people how to do the product rule, I don't need to make them memorize that thing. What we do here in my classes is we list f and g. So f is 1 minus 7t. G is the inverse hyperbolic cotangent of square root of 7t. Now down here, we do the derivatives of them. The derivative with respect to t of this first one is negative 7. Because the 1 disappears, t cancels out. Now, this will use our formula we just had here. So we're going to be using d dx cotangent u is equal to u prime over 1 minus u squared. So let's find the derivative of cotangent. So first off, we know that the numerator is going to be 7 over 2 radical 7t. That's the u prime. Minus, or divided by 1 minus u square root of 7t squared. So we have on top and on the bottom, the square root of the 2 cancel, so we have 7t. So this becomes, take the top, leave it alone, and multiply by the flip of the bottom, which is 1 over 1 minus 7t. And since they're multiplied, it's just one big division. So that's my g prime. So the derivative is start from here, and since it's a product, we use a plus sign. So we take g f of prime plus f g of prime. So we have negative 7 times hyperbolic inverse cotangent of square root of 7t. That's this times this, plus 1 minus 7t times this equation, times 7 over 2 radical 7t times 1 minus 17. Since these are multiplied, this and this cancel. So that leaves negative 7 cotangent hyperbolic inverse of radical 7t plus, those are canceled. We have 7 over 2 radical t. Now we could rearrange these. We could put 7 over 2 radical 7t minus 7 cotangent inverse radical 7t. And again, it's if you want to take like the picture you sent me, since they both have a coefficient of 7, we can factor that out. Minus cotangent hyperbolic of radical 7t. And there's your first derivative of that hyperbolic function. All right. Let's look at the second. Second one is almost identical. Actually, it is, since it's the same function. Question number 2. 1 minus 2. Instead of theta, I'm going to use x because my thetas are called awful. So I'm going to use x. Hyperbolic, inverse hyperbolic cotangent of 2x. Remember, thetas are x's. So we're trying to find the first derivative. So this is, since we have a product, this is f, this is g. So it's 1 minus 2x. G is the cotangent inverse of 2x. F prime, the derivative of this one makes it negative 2. And the derivative of this one, again, we have to use the same function, because remember the derivative of inverse cotangent hyperbolic of u is equal to u prime 1 minus u squared. This is the formula we'll be using for the g. So since my u is 2x, my u prime is 2. So the numerator is 2, 1 minus 2x squared. So since it's a product, we're going to go the fishy thingy. And since it's a product, we use a plus. If it's a quotient, we use a minus. So we have negative 2 times the inverse of the hyperbolic cotangent of 2x plus 1 minus 2x times 2, 1 minus 2x squared. All right. What can we do here? We have 1 minus 2x. And inside this parenthesis, what we have here, we have 1 minus 2x squared. This is the difference of two squares. Remember, a squared minus b squared is a plus b, a minus b. So it's going to be 1 plus 2x times 1 minus 2x. Since they're multiplied, this and this cancel, but 1 minus 2x is cancel, which leaves us with negative 2 inverse hyperbolic cotangent of 2x plus 2, 1 minus 2x. You have to make it look like the picture. We can factor out a 2. We can put this in front, so we have 1 over 1 minus 2x minus the inverse of hyperbolic cotangent of 2x. So I just took the 2 out. That's a negative in front of the cotangent. So there's your derivative. All right, I hope that helped. Good luck. And I'll be here for you whenever you need me.